Okay, hello everyone. You're all welcome to my video. In this video, I'm going to be solving questions and answers. We are looking at waec 2022 past questions. Okay, I remain your tutor, Mr. Life Changer. So do well to subscribe, like, share, follow, depending on the platform you are in. Okay, so we go. The first one says the byproduct of fermentation of sugar is the answer is carbon 4 oxide. Carbon 4 oxide is a byproduct of fermentation. The reaction of fermentation is glucose breaking down by an enzyme zymase to give us alcohol and carbon 4 oxide. So this is the reaction for fermentation. So carbon 4 oxide is the answer. Okay, the second one says, which of the following sugars is a product of the condensation of monosaccharides? Which of the following sugars is the product of condensation, of monosaccharides? Now, the condensation of monosaccharides, two monosaccharides gives us a polysaccharide, okay? And so galactose is mono, maltose is poly, so the answer is maltose. Okay. Now you should know that condensation of two glucose plus glucose, is going to give us maltose. Okay. Glucose plus galactose. Galactose. Condensation there's always water involved. Okay. Glucose plus galactose will give us lactose, plus water. Then glucose plus fructose would give us sucrose plus water. Okay, that's important for you to note. Okay, so the next one says the cleansing effect of soap is low in acidic water because. Now, being low in acidic water is because of, the answer is the hardness of acidic water. Okay, acidic water is quite hard, so it is quite difficult for cleansing to take place in acidic water. Now, the next one says the following compounds are a condensation polymer except now, condensation polymer, just like we saw earlier, is formed by addition of two monomers with a small molecule being removed. Okay, there are two types of polymerization. There is addition, and there is condensation. Okay, so all of them here are condensation. The only one that is not condensation is polyethylene. Polyethylene is not condensation because from the word ethene, it has a double bond, and double bond means that it requires addition. Okay, it requires addition polymerization. The monomers that require addition polymerization are usually characterized with double bonds. Please note that. While the one that requires condensation, they are usually characterized with COOH, alkanoic, OH, amine group, and so on and so forth. So please, that's an important thing for us to note. Now the other one says, number 5 says, what amount of electricity is required to deposit 1 mole of aluminium from a solution of aluminum chloride? Okay, 1 mole of a substance is deposited by NF quantity of electricity. That's the rule. 1 mole of a substance is deposited by NF quantity of electricity. So since we are asked for 1 mole, N in this case is the number of charge or number of electrons. In the case of aluminium, is plus 3. So that means the answer will be 3F. It will deposit 3 Faradays. C is the answer. Okay, the next one says, which of the following compounds will react rapidly with bromine? Now, a compound that will react rapidly with bromine, these are all organic compounds, so they will be unsaturated compounds. unsaturated compounds. And the reason is because bromine can easily add to a double bond. So the answer is hexene. And this is what it looks like. Let me say I have, this is hexene. Okay, now if I add bromine, this is hexene, bromine gas, one would add here, the other will add here. So you're going to get something like this, CH2Br, then CHBr, then CH2, 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 CH3. Okay, let's not forget that. This is one of the properties of alkenes, addition reaction. Now the next one says alkanols can be manufactured from alkenes by the initial reaction of alkenes with. Okay, that's a very important. The answer is concentrated tetraoxosulfate 6. Now we would have picked this, but the kind of alkanols that is formed here are what we call diols. If I take an alkene, for example, in the presence of KMNO4, either acidified or alkaline, I'm going to get CH2OH and CH2OH. So it's not bad. But this is not the answer, because it says the initial reaction of alkenes, because there are two steps. Now, but when alkenes, for example, ethene reacts with water, for example, you are going to get CH3, then CH2OH. That's addition reaction. Hydrogen will add here to become CH3. OH will add here to become CH2OH. Okay? And this reaction takes place in the presence of an acid. But this reaction involves two stages. The stage one of this reaction is ethene reacting with the acid. You have C2H4 reacting with the acid plus H2SO4 to give us ethyl hydrogen tetraoxosulfate 6. Cu2H5HSO4. Sorry, this should be CuH5 then HSO4. Okay, that's ethyl hydrogen tetraoxosulfate 6. Okay, that's the first stage, which is what they are being asked here. Then the stage 2 now would be the ethyl hydrogen tetraoxosulfate 6 can now react with water, in this case now, to form ethanol, C2H5OH. Then you get back your acid, because the acid is serving as a catalyst in this case. So B is the answer to this question. Now the next one says, which of the following statement about the standard hydrogen electrode is not correct? A says hydrogen gas is at a pressure of 1 atmosphere. This is correct. B says a solution of 1 mole per dm cube of hydrogen ion is used. This is correct, because the standard state concentration must be 1 mole, pressure must be 1 atmosphere. A platinum electron is used. This is correct. The temperature is kept at 20 degrees Celsius. No, this is not correct. The temperature must be standard temperature, and standard temperature is 25 degrees Celsius. Okay, that's very important. Now, for those of you that don't know, I think it looks like this. This is the platinum electrode. Then you have a space here where hydrogen is being pumped into. Then, of course, connected to the other electrode. Both of them are in their solutions, and so on and so forth. But that's by the way. That's a topic on its own. Okay, so that leads us to the next one, number 9. It says, if 60 grams of M combines with 20 grams of oxygen, what will be the empirical formula of the compound? Okay, to know empirical formula, we start by writing the elements. So the elements here, we have M and oxygen. Then we write their masses. The mass here is 60 grams. The mass of oxygen is 24 grams. We write their relative atomic masses or molar masses. This is 120. Oxygen is 16. Then we find their number of moles. Okay. So number of moles means to divide. 60 divided by 120. This would give us 0.5. Here 24 divided by 16. This will give us 1.5. And of course 1.5, whenever you see 1.5, do not approximate. All you need to do to make them balance. Okay, but before you do this, you divide by the smallest ratio. Divide by smallest ratio. So 0.5 is smaller, so I'll divide by 0.5. Then here will be 1.5 divided by 0.5, right? And this would be 1 and this would be 3. So the answer is MO3, so which is C. So number 10 says the product of electrolysis of dilute, now look at the word dilute sodium chloride using carbon electrode is very simple. At the anode and the cathode, because it is dilute, the product at the anode is definitely oxygen. Electrolysis always gives oxygen at the anode whenever you are using carbon electrodes or you are using inert electrodes. Anode is always oxygen, except if this was concentrated, then we would have said chlorine gas. So chlorine will not be mentioned here because it is anode. In the case of cathode is always hydrogen, always. So hydrogen. Now the only time it is not hydrogen is if the metal it is competing with, if like for example sodium, it is a metal lower than hydrogen in the electrochemical series, like copper, silver, gold, and all of that, right? So if not, it is hydrogen. But and also, if assuming this electrode now was a mercury electrode, then sodium will be discharged, sodium will be produced if it was a mercury electrode. But if it is inert electrode, always expect oxygen, except the metal is lower than hydrogen. Sorry, always expect hydrogen, except the metal is lower than hydrogen in the electrochemical series. So the answer is oxygen and hydrogen, so which is B. Okay. Now the next one says determine the quantity of electricity used when a current of 0.2 amperes is passed through electrolytic cell for 60 minutes. Now quantity of electricity based on this question is simply IT. I is current, T is time. So the current is 0.20. The time is 60 minutes. 60 minutes means 60 times 30 seconds. So that will be 0.2 times 1800. That will be 360 coulombs. So C is the answer to that question. I believe it making sense. Now oxochlorate 1 acid is used as a bleaching agent because, now this is important for you to know, it is because it is an oxidizing agent. Now there are two major bleaching agents you should know. One of them is chlorine. Now chlorine actually dissolves in water to give us two different acids. You have oxochlorate and you have HCl. Now this oxochlorate is what now goes into water under sunlight. Okay, under sunlight it becomes HCl, then gives this oxygen which is required for bleaching. So chlorine bleaches by oxidation, or you say oxochlorate 1 bleaches by oxidation. But the other bleaching agent is SO2. SO2 bleaches by reduction. I like you to compare that. SO2 bleaches by reduction, but chlorine, or you can say oxochlorate, bleaches by oxidation. Very important. Now the next one says the IUPAC name for this. Okay, I think you can look for my video where I taught how to write and name organic compounds. We should, before we can name this, we should write it out correctly. This is written in a condensed form. So I start with CH3. After CH3 is CH. CH3 can never be in between, so it has to be a branch like this, CH3. Then after that we have another CH. Then we have chlorine. Chlorine is not part of the chain, it has to be a branch. Then after that we have another CH. CH3 also is always a branch. Can you see that? Then we have CH2. Then we have CH3. So this is the correct thing. And the longest chain is 1, 2, 3, 4, 5, 6. So 6 means hexane. Hexane is the parent name. And if you look at this very well, you see that counting from here will be the lowest possible. Counting from here is better because it's closer. So you have 1, 2, 3, 4. So in this case now I'm going to have 3 chloro. I'm writing chloro first because alphabetically C comes before methyl. Always write alphabetically. Then methyl is 2,4-dimethyl. So you have 2,4, then dimethyl hexane. So 3 chloro, 2,4-dimethyl hexane. D is the answer to that question. I believe that makes sense. Now the next one says A colorless gas with a pungent smell is evolved when dilute hydrochloric acid is added to a sample of a salt. The gas evolved could turn. Now, a colorless gas with a pungent smell is evolved when a dilute hydrochloric acid is added to a sample salt. Okay, the gas evolved could turn. First of all, the gas is a colorless gas, and the gas it has a pungent smell. Okay, when hydrochloric acid is added to a salt. Okay, so the gas evolved could turn. Now, the kind of substance that can give the kind of gas that gives a pungent smell, it is not CO2, it is definitely an SO2. Okay, it is definitely SO2. Now, the reason why I said SO2 is because hydrochloric acid is an acid. It is not acid. Not all acid is added to gas, or not all salts liberate gas when an acid is added. For example, the only salts that can liberate gases are carbonates and sulfates. Those are the only salts that can liberate gases. And if I add acid to this particular one, Na2CO3, you are going to liberate CO2. Now, CO2 is colorless, but it's not pungent. CO2 is also is odorless. Now, but when you add, sorry, this should be SO3. When you add HCl to an SO3, a gas will be released, which is SO2 gas. Okay, there is no other salt that can release gas in that manner whenever an acid. You see, that's why it's important for you to know the properties of acid. One of the chemical properties of acid is that acids can react with a triiosocarbonate to liberate CO2, or can react with a trioxosulfate to liberate SO2. And SO2, like we said, is a reducing gas, is a reducing agent. So it is going to turn acidified KMNO4 to become colorless. That is exactly what it is going to do. Okay, and that is the answer to that question. Okay, so SO2 is a reducing gas, very important. Now, the next one says, if 5.0 grams of marble reacts with 25 cm cube hydrochloric acid, which one of the following combinations has the fastest reaction rate? Okay, so there are certain factors that have reaction rate. If you notice the options, is B, C, D. Marble chips, powdered marble always reacts faster than marble chips, so that means the answer has to be C or D. Now, if I compare the concentration, the higher the concentration, the higher the rate of reaction. Increase in concentration always increases the rate of reaction, so the reaction is C. Is B, C, D, so the reaction is C. Okay, I mean the answer is C. Now, number 16, increasing the temperature generally decreases solubility of a solid in a liquid, but increases the solubility of a gas in a liquid. B, increases the solubility of a solid in a liquid, but decreases the solubility of a gas in a liquid. And the answer is B, generally speaking. Okay, generally speaking, when you increase temperature, it's easier for solid to dissolve in a liquid, but gases do not dissolve well in increased temperature. Yeah, that's the answer. Now, the next one says, a white precipitate was formed when barium chloride was added to an aqueous solution, okay, of a salt X. The precipitate dissolved in dilute HCl with rapid effervescence. The salt is likely to be. Now, the barium salt, anytime you see barium chloride added to a salt and it gives a precipitate, right, it means that it is either SO4 ion, SO3 ion, or CO3 ion, because barium sulfate is insoluble in water, barium triisosulfate is also insoluble in water, and barium carbonate is also insoluble in water. So it could be any of those three ions. Okay, but now what differentiates them is that the precipitate dissolves in dilute HCl with rapid effervescence. Now, the only one here that can dissolve in HCl with a rapid effervescence is actually barium carbonate, because the effervescence of the gas is going to be CO2. CO2 is, gives effervescence as it is released. So the answer to that question is CO3 2 minus. I hope that makes sense. Okay, so now the next one, number 18. Before a reaction should take place, there should be first of all the breakage of bonds of reactants. That's the answer to that question. The breakage of bonds of reactants. Number 19. Consider the following reaction equation: CaO plus SiO2 giving us CaSiO3. Silicon 4 oxide in this case is acting as this is silicon 4 oxide, but this is calcium trioxosilicate 6. If you calculate the oxidation number of silicon here is plus 4, because oxygen is minus 2. Minus 2 times 2 is minus 4. That makes silicon plus 4. But here calcium is plus 2. Oxygen is minus 2 times 6, which is minus 2 times 3, which is minus 6. 2 minus 6 is a minus 4. Okay, that makes silicon here also plus 4. Okay, so that means my assertion was wrong. There is no change in oxidation number. Oxidation number did not change, so we cannot say a reducing agent. Okay, so and we cannot say oxidizing agent, because the only time you can call a species a reducing agent or an oxidizing agent, it simply means that there is a change in oxidation number. So that is not the answer. But in this case now, you can see that calcium oxide is a base. It is a base because it is an oxide of a metal. Oxides of metal are bases, whether it is oxide of a metal or oxide of a non-metal. Like sodium oxide is a base, and sodium hydroxide is also a base. So calcium oxide is a base. That makes silicon oxide acting here now as an acidic oxide. That's the answer to that question. So silicon oxide in this case is acting as an acidic oxide, as a base plus acid will give us a salt. That is beautiful. Okay, so that leads us to this: which of the following acid will form normal salt only? Now, the acids that form normal salt are monobasic acids. They cannot form acid salt. Monobasic acid. That means monobasic acid means acid that has only one ionizable hydrogen. One ionizable hydrogen. And the only one I can see here is this, because this one here is H2SO4, has two ionizable hydrogen. This is HNO3, this one has only one. Tetraoxophosphate is H3PO4, this one has three ionizable hydrogen. Triazosulfate, this one is H2SO3, this one has two ionizable hydrogen. That's very important for us to note. Now the next one says, what is the partial pressure of oxygen at STP in a gas mixture containing 100 cm cube of oxygen and 900 cm cube of nitrogen? Okay, the partial pressures at STP. Now STP simply means standard temperature and pressure, and STP is 1 atmosphere. You see that? So it's 1 atmosphere. So we will need to find the partial pressures of these guys in this. So in the case of oxygen, we can say 100. The volume of oxygen all over the total volume of the gas is 1000, because the total volume is 100 plus 900 is 1000. Okay, and multiplied by 1 atmosphere. So this will give us 0.1 times 1 atmosphere, and that would give us 0.1 atmosphere. So that's the answer. So the answer here is B. That's very, very important. Okay, I think that will be it for that. Now there is something else you can do, but this is the easiest way to go about it. If you want to find the partial pressure of nitrogen, it will be 900 over the total is 1000, then multiplied by the 1 atmosphere, and you will get that. Now the next question says, graphite is used as dry lubricant due to the presence of the reason why graphite is used as a dry lubricant is because of its layered structure. It can even easily slip over one another. Diamond is what has octahedral structure. Free and mobile electrons are the reason why graphite can conduct electricity. But in the case of being a lubricant, the answer is the layered structure. I hope that makes sense. Now the next one says, which of the following gas is alkaline? The only alkaline gas that exists is ammonia. All other gases are acidic gases or neutral gases. Okay, yes. Now this one now says, which of the following statements about an equilibrium system is correct? Okay, A says forward and backward reaction happens at the same rate. That looks like the correct answer. B says the concentration of reactants must be equal to that. No, that's not true. C says the concentration of reactants and products can be changed by adding a catalyst. That's not true. A catalyst does not affect it. The concentration of the reactants and product are not affected by change in temperature. That's not true. So the answer is A. A system is said to be in dynamic equilibrium or in equilibrium when the rate of the forward reaction is equal to the rate of the backward reaction. Let's kindly note that. Okay, so now the next one we are going to look at is this. It says consider the following reaction equation, and we are given this. Increasing the temperature of the reaction would, increasing the temperature of a reaction would. Now temperature, the way temperature affects a reaction is dependent on whether the reaction is endothermic and exothermic. Now, but if you can notice here, delta H is minus 92. That makes it exothermic. And for an exothermic reaction, increase in temperature will favor the backward reaction. For an exothermic reaction, increase in temperature will favor the backward, but decrease will favor forward. So the answer is that it will favor backward. It will shift the equilibrium to the left. Okay, this one right? No. Increase the yield of ammonia. No. Ammonia is to the right. Decrease the amount of hydrogen. No. It will increase the amount of hydrogen. Decrease the yield of ammonia. Yes, correct. Because it is shifting to the left. So that means the ammonia the yield of ammonia will decrease, and rather, this is kind of a reverse psychology question. So it's important for you to know. Assuming it was endothermic, increase in temperature will favor the forward, and vice versa. Okay. Now that leads us to the next one. When air in a syringe is compressed so that there is no change in temperature, is compressed so that there is no change in temperature. A, the air liquefies. B, the pressure increases. C, intermolecular spaces increases. D, density increases. The answer is very simple. The pressure increases, because once there is no change in temperature, it means constant. Boyle's law takes into play, where we say pressure is inversely proportional to volume. So compression means you are reducing the volume. Reducing the volume means you are increasing the pressure. Very, very important. Okay, you see? Common sense. Now the next one says, which of the following statements about liquids is, are, or true? Which of the following statements about liquids is, are, or true? I, liquids maintain their volume at constant temperature. I, liquids have fixed shape. I, liquids do not diffuse. Then IV, change in pressure affect volume of liquids. Which of the following statements about liquids is or are true? Okay, now liquid maintain their volume at constant temperature. Yeah, liquids have a fixed shape. Liquid does not have a fixed shape. They have fixed volume but not fixed shape. Okay, but liquid do not diffuse. Yes, liquid do not diffuse. That is also correct. Change in pressure affect volume of liquids. No, change in pressure does not affect. It's not incompressible. So the answer to this question is I and I. Okay, but we don't have. We have I. Liquids maintain volume at constant temperature. Yeah, that means has a fixed volume. This is wrong. Liquids do not diffuse. Liquid do not diffuse. Liquids do not have a fixed shape. Change in pressure affect volume of liquids? Okay, actually the answer should be I and I, because liquid actually truly do not diffuse, but we don't have the option here. So I would go for A, that means I only. Okay, because change in pressure does not affect the volume of liquid. Change in pressure can affect the volume of a gas, but not the volume of a liquid. Okay, so the next one says a hydrogen chloride gas reacted with oxygen gas to yield water and chlorine gas. Okay, the mole ratio of hydrogen chloride gas to water is, let's see, hydrogen chloride gas reacts with oxygen to produce water and chlorine gas. If we should balance this equation, I think this should be, let's see, this should be 4 and this should be 2, and chlorine should be 2. I think the equation is balanced now. 4 hydrogens, 4 hydrogens, 4 chlorines, 4 chlorines, 2 oxygens, 2 oxygens. So this is exactly what we are going to get. Okay, so the mole ratio of hydrogen chloride gas to water. This hydrogen chloride gas, it is 4. Water, the mole is 4. Water, the mole is 2. So this is the same thing as 2:1 if I divide both sides by 2. So B is the answer to that question. Quite easy. Now the next one says, number 29, what number of moles of oxygen would exert a pressure of 10 atmosphere at 320 Kelvin in a 8.2 decimeter cube cylinder? And we are given R to be this. Okay, R is 0.082 atm dm cube per mole per Kelvin. Now in a question like this, the best formula to use here is the ideal gas formula, PV equal to nRT. And since we are looking for number of mole, your N is going to be PV over RT. Your P is pressure, which is 10. Your V is volume, which is 8.2. Your R is a constant, 0.082. Then your T is temperature, which is 320. So let me use my calculator here. This is 10 times 8.2 divided by 0.082 times 320. Okay, that is going to give me 3.125. So the answer is C, which is approximately 3.13 to 2 decimal place. Now the next one says, if 50 cm cube of a saturated solution of KNO3 at 40 degrees Celsius contained 5.05 grams of the salt, okay, its solubility at the same temperature would be, now solubility of a salt, the formula for solubility is equal to number of moles of solute, okay, that can saturate the solution, number of moles of solute that can saturate the solution, now divided by the volume of solution in dm cube. Now if you use this formula, your answer is supposed to be mole per dm cube. What I like to say is that you can also say mass over volume if the unit is in grams per dm cube, grams. But here we have moles, so we use this. And the number of moles, for us to find the number of moles of the solute, the molar mass of KNO3 is 101. So I can say number of moles is mass over molar mass, so which is going to be 5.05 divided by 101, and this is obviously going to give us 0.05. Let's see, 5.05 divided by 101, yeah, 0.05. So that means this is going to be 0.05 mole divided by the volume. The volume is 50 cm cube. You can divide 50 divided by 1000. That will also give us 0.05. So 0.05 dm cube. Dividing cm cube by 1000 will give us dm cube. So that's what we have here. So 0.05 divided by 0.05 will give us 1. So the answer is 1 mole per dm cube, so which is A. Okay, I hope that makes sense. Now the next question here says, which of the following elements will displace copper from a solution of copper ions? That element must be higher than copper in the electrochemical series, and the only element here that is higher is lead. Okay, lead in your electrochemical series, lead is higher than copper. Now the next one says, what is the percentage composition of carbon in CaHCO3? Okay, percentage composition of carbon will be equal to the amount of carbon. This is the real structure. There should be a 2 here, a subscript. That's the real formula. So we have 2 carbon. So I will say 2 carbon all over CaHCO3, then 2, then multiply by 100. So carbon is 2 times 12 divided by, now CaHCO3 2, calcium is 40. We have 2 hydrogen, that makes it 2 times 1, plus we have 2 carbon, that makes it 2 times 12 because the molar mass of carbon is 12. Then plus we have 6 oxygen, so that will be 6 times, oxygen is 16. So that will be 40 plus 2 plus 24 plus 6 times 16 is 96. Okay, so this would be, this is 120, 160, 162. So all of this is 162. So this will be divided by 162 times 100. So so if we calculate that, 24 divided by 162 multiplied by 100 is going to give us 14.81%. So the answer is B, 14.8%. Okay, makes a lot of sense. Now the next one says, which of the following bond types is intermolecular? Okay, now we only have 3 okay, there are some. The intermolecular forces we have van der Waals forces is one of them. Another intermolecular force is called metallic bond. Okay, another intermolecular force is called hydrogen bonding. Okay, so these are the 3 major intermolecular forces. There are others, but for our level we limit it to this. These are the 3 intermolecular forces that we have. So among all of these here, the answer here is hydrogen bonding. The reason why I will not take metallic bond, because metallic bond is even as strong as ionic bond, holding metals together in a bond. Okay, so that's the best that's the best answer for that question. Now number 34 says, the maximum number of covalent bonds formed by nitrogen is, the answer is 3. The reason is because nitrogen has 5 valence electrons. Nitrogen is the 7th element. The configuration is 2,5, meaning it has 5 valence electrons. So nitrogen, you have 1, 2, 3, 4, 5. So nitrogen needs just 3 more electrons to make it balance. So you have this, the first one, like in the case of ammonia, you have another hydrogen here, you have another hydrogen here. So you see, it can only form 3 bonds. 3 bonds, then 1 lone pair. This one here is called a lone pair. It's on its own. It does not form a bond. Lone pair is that pair that does not form bond, but the other ones are called shared pairs. Shared pairs, and which is a bond. Okay, so 3 bonds is the answer. I hope that makes sense. Now the next one says, the IUPAC name for this is, okay, to get this correctly we have to write this in full. You have CH3 attached to CH, then CH3 definitely is a branch. Whenever you see an alkyl group like methyl, is always a branch. And you have CH, okay, and you have CH2. If you notice, the bonds around these two are not complete. This one has 3 bonds. This one also has hydrogen and 2 bonds, making it 3 bonds. So that means there's a double bond between them to make the bonds perfect and complete. So whenever you have a functional group, your functional group must take the lowest possible number. So you should count 1, 2, 3, 4. Okay, that's boot 1 in. Boot 1 in because double bond is in position 1. So 1, 2, 3. The answer is 3 methyl or methyl boot 1 in. 3 methyl boot 1 in. So the answer is C. Okay, so these are things that you are meant to know. So the next one says ionization energy increases across the period of the periodic table because. Now, the only reason why ionization energy increases across it is because effective nuclear charge increases. That's all. The effective nuclear charge increases. Most of the changes you see across the period is related to the effective nuclear charge. Okay, please don't forget that. And effective nuclear charge increases as atomic number increases, but the answer, the direct implication, is effective nuclear charge. Okay. Now the next one says, which of the following properties indicate that an element is a metal? I. It reacts with oxygen to form acidic oxide. No. Metals form basic oxide, not acidic oxide. Okay. It forms ionic chlorides. Well, yes. Most metals form ionic chlorides. I has a variable oxidation state. No. It is only transition metals that have variable oxidation state. IV displaces hydrogen from dilute HCl. Yes. So the best answer here is II and IV. II and IV. So C is the correct answer. Okay. Now the next one says the electron configuration of carbon atom in its excited state is, you see, I've taught this many times. Now, if you want to write the configuration for the ground state of carbon, the ground state of carbon is 1s2, 2s2, 2p2, because carbon has only 6 electrons. Or you can just say 1s2, 2s2, 2px1, 2py1, then 2pz0. There's nothing in 0. That's for the ground state. Now, but when we say excited state of carbon, excited state simply means that an electron has moved from one s orbital to fill this empty p orbital, and so it is now going to be 1s2, 2s1 now, 2px1, 2py1, and 2pz1. So that's the answer. 1s2, 2s1, 2px1, 2py1, and 2pz1. So the answer to this question, do we have an answer here at all? The answer to this question is supposed to be C. I think there's a mistake here. This guy is supposed to be 1 here. This is supposed to be 1, not 2. So and this is also supposed to be 1, not 2. So that makes C the correct answer. None other is correct. This is how it should be. Kindly take notes, please. Okay, the next question says an oxide, and that's number 39. An oxide has the following properties. It is a white powder, reacts with HCl, reacts with sodium hydroxide. It is insoluble in water. Now let me say this. For the oxide to react with HCl and also react with sodium hydroxide, that means it reacts with both acid and also reacts with a base. Is definitely an amphoteric oxide. Only amphoteric oxide that have acidic and basic property. They can react with acid, they can also react with what? A base. That is very important. Okay, the next one says, which of the following statements about atoms of metals are correct? A. They readily accept electrons. No. They are soft. No. They are held together by covalent bond. No. They are held together by a sea of electron cloud. Yes. Actually, what holds them together is what we call metallic bond, but a sea of electron cloud binds them together like this. Surround them. Okay, metals are not soft. Only metals like sodium and potassium are soft. Okay, and metals do not accept electrons, they give out electrons. And metals can never form a covalent bond. Okay, they only form ionic bond or metallic bond. Okay, now this one says the atom with electron configuration this is in. Okay, from the what you want to know is the outermost shell. This is the outermost shell here. This is the outermost shell here. So it is definitely a period 4 element. Okay, it's a period 4 element, and it is also a p block element because the configuration ends with p. Can you say that? Is a p block element because the configuration ends with p. So the answer is period 4 and p block. That's it. If the configuration ended with D, we would have called it a D block element. If the configuration ended with S, we would have called it an S block element. Okay, that's very important. Now the next one says the electropositivity of elements across the periodic table. Normally, electropositivity always increases down the group but increases across the period. So the answer is B. Electropositivity increases decreases. Oh, sorry, that's wrong. You know, it is metals that is electropositive. As you go across the period, it becomes more metallic. So it decreases across period. It decreases across period because if you keep going, it keeps getting, let me take like period 3. So you can see that as you are going across the period, it is becoming more electronegative and becoming less electropositive. So it decreases across the period but increases down the group. Okay, so decreases across the period is the answer here. Okay, now the next one says consider the following table. We have this table. Which of the substance is a liquid at room temperature and rapidly evaporates on exposure to air? I've told you before, room temperature is actually 25 degrees Celsius, and a liquid will always have its melting point lower than 25 degrees Celsius and its boiling point will be higher than 25 degrees Celsius. So that's what makes this one wrong. The melting point is lower but the boiling point is also lower, so that's wrong. So the answer can either be Q or R because both of them have lower melting point than 25 and higher melting point than 25. But the most accurate now is going to be Q because this one has a low boiling point. When you say something has a very low boiling point, it means that that thing can easily vaporize. A little heat causes it to vaporize. Okay, so this has a lower boiling point than this. This one you need to heat it before it gets to boil. That's important for you to know. Now the next one says which of the following oxide is amphoteric oxide? The answer is lead oxide. I don't need to waste time there. You have zinc oxide, you have aluminum oxide, and you have lead oxide. These are the major amphoteric oxides. Lead oxide, PbO. Okay, very important. There are some others, but for your level you should know that. Now the next one says which of the following processes occur during fractional distillation of petroleum? A says condensation and diffusion. B says diffusion and evaporation. C says diffusion and sublimation. D is the answer, evaporation and condensation. Because fractional distillation, first of all, is a method used to separate mixture of liquids that have different boiling points. And the process is that you heat the liquid until when it gets to a boiling point of any of the liquid, it evaporizes. Then when it passes through the fractionating column, it condenses and is now received as a liquid, right? So it's evaporation, then condensation. Okay, I would rather use the word vaporization and condensation, but that's okay. Now if the molar mass of X this is 162, the question is not complete. I think we are asked to find X, and so to do that we have X plus hydrogen is 2, that's 2 times 1. Carbon is 12, we have 2 carbon, which makes it 2 times 12. Oxygen is 6, so we have 6 times 16, all equal to 162. So this will be X plus 6 plus 14, plus 24 plus 32 is 162. This is X plus, this is 56 plus 58 is equal to 162. So X is going to be 162 minus 58. So 12 minus this is 4, right? I hope I'm correct. Yeah, 12 minus this 4, and this is O. then this is 1. So the answer should be 104. Okay, so I can already see that there is a mistake here somewhere, so I may not, I guess it's going to be D, but 104. So please note that. So that would be the molar mass of X, if that is what is asked. Now the next question here says charcoal is used in the decolorization of sugar because of its adsorption property. Charcoal has what we call adsorption. To adsorb means that it attracts things to its surface a lot. Yeah, and charcoal, all forms of charcoal, whether it is sugar charcoal, wood charcoal, all charcoal, has a very good adsorption property, and they are used to decolorize, substances. Now the next one says the first definition of an element was first made by, the answer is Dalton's atomic theory. That's where we have the Dalton's atomic theory. That's according to sciences, but philosophers already defined atom many years ago. Now, which of the following scientists formulated the law of conservation of mass? It is the same Dalton that formulated the law of conservation of mass, that matter cannot be created nor destroyed, but can be transformed from one form to another. Okay, so the next one, we have this pressure against volume, and they say which of the following sketches is a graphical representation of Boyle's law? Boyle's law is P against 1 over V is a straight line. This is the answer. Boyle's law, you can have this. When you have P against 1 over V, or reverse, you have this. If it is P against just V, it's going to be like this. This is Boyle's law. In the case of Charles' law, it is pressure, okay, it is volume against temperature. If the temperature in Kelvin is a straight line like this, but if the temperature is in degrees Celsius, it's going to be like this, and you're going to dot until you get here, and this temperature is minus 273 degrees Celsius, and here is 0 degrees Celsius. It's quite important that we know these things. Okay, so that is it for this. Thank you very much. So you can check my other videos for more videos. Click like, subscribe, follow, and all of that. Thank you. See you in my next video.